I'm Diallo Cummings, and in this session we'll take a look at partial decomposition of fractions. In the technique for finding partial fraction decomposition of a rational function f of x divided by g of x, for each distinct linear factor ax plus b, the decomposition must include the term a divided by ax plus b. For each repeated linear factor ax plus b quantity raised to the power m, the decomposition must include the terms a sub 1 divided by ax plus b plus a sub 2 divided by ax plus b quantity squared plus a sub m divided by ax plus b quantity raised to the power m. Here's the technique for decomposition into partial fractions. The first step is we'll multiply each side of the resulting equation by the common denominator. Secondly, we'll substitute the 0 for each factor into the resulting equation. For repeated linear factors, substitute as many other numbers as is necessary to find all the constants in the numerators. The number of substitutions required will be the number of constants a, b, and so on. There is also a method for quadratic factors, which we'll take a look at in another tutorial. Now let's take a look at an example. And in this first example, we will find the partial decomposition for the function 1 over t squared minus 4t. And the first thing I'll do in order to find the partial decomposition is I'll factor the denominator. So I'm going to rewrite 1 over t squared minus 4t as 1 over t times the quantity t minus 4. And I'm going to write this as a over my first factor t plus b over the second factor in my denominator, which is t minus 4. The next thing I'll do is I'll try to find the constants a and b. So the first step is we'll multiply both sides by the common denominator, which is t times the quantity t minus 4. So I'll simply multiply the left hand side by the least common denominator, which is t times the quantity t minus 4. And I'll also multiply the right hand side of the equation by the least common denominator t times the quantity t minus 4. When we multiply the least common denominator by the left hand side, it cancels with the denominator, so we're left with 1. On the right hand side, I'm going to distribute the least common denominator. So when we distribute the least common denominator with our first term, the t variable cancel. So I'm left with a times the quantity t minus 4. I'll distribute the least common denominator with our second term. Notice that the t minus 4 cancels. So I'm left with b times t. And we'll use this equation to find our constants a and b. So the first thing I want to do is I want to use this equation. 1 is equal to a times t minus 4 plus b times t. And I'm going to substitute t for 0. That'll allow us to solve for our constant a. So I'm simply going to substitute t for 0. And we see that 1 is equal to negative 4a. I'll divide both sides by negative 4. So a is equal to negative 1/4. The next thing I'll do is I'll find the constant b. So I'm going to take our equation. 1 is equal to a, and notice we found a earlier, which was negative 1/4. So I'm simply going to substitute that into our formula. Times t minus 4 plus b times t. And in this instance, to solve for b, I'm simply going to substitute t for positive 4. So we have 1 is equal to negative 1/4 of 4 minus 4 plus 4b. And we have 1 is equal to 4b. Therefore, b is equal to positive 1/4. So we'll substitute these two values into our equation. So we have a over t, and recall that a is negative 1/4 divided by t, plus b over t minus 4, and recall that b was 1/4 divided by t minus 4. And once we clean this up a little bit, we see that we have negative 1 over 4t plus 1 over 4 times the quantity t minus 4. Now we'll take out a look at another example that has repeated factors. And in this example, we want to find the partial decomposition for the function 1 over x times x plus 1 quantity square. So here we see we have the factor x plus 1 has been repeated. So I'm going to write this out as a divided by x plus b divided by x plus 1 plus c divided by x plus 1 quantity square. And now I'll attempt to find the constants a, b, and c. So the first thing I'll do here is I'll multiply both sides by the common denominator, which is x times the quantity x plus 1 squared. So we'll simply multiply that by both sides of our equation. So when we multiply the least common denominator by our left hand side, notice that it cancels the denominator. We're left with 1. On the right hand side, we're going to distribute. When we multiply the least common denominator by our first term, notice that the x variable cancels. So we're left with a times the quantity x plus 1 squared. When we distribute with the second term, notice that our x plus 1 factor cancels. So we're left with bx times the quantity x plus 1. And when we distribute with our last term, the x plus 1 quantity square factor cancels, and we're left with c times x. And in this equation, we'll use to find a, b, and c. So the first thing I'll do is I'll let x equal 0. Therefore, we can solve for our constant a. So I have 1 is equal to a times the quantity x plus 1 squared plus bx times x plus 1 plus cx. We're going to let x equal to 0. And once we substitute x for 0, we see that 1 is equal to a. So I'm going to substitute 1 for A, and I'm also going to substitute X for -1, and that will allow us to solve for our variable C. So I'm simply going to rewrite this formula. 1 is equal to A, which is 1, times X plus 1 squared, plus bx times x plus 1 plus cx. We're going to substitute x for -1. And once we substitute x for -1, we see that -1 is equal to c. And lastly, I'm going to take our equation once again. I'm going to substitute c for -1, and I'm going to substitute x for 1, and it should allow us to solve for our constant b. So I'm going to write this as 1 is equal to 1 times x plus 1 quantity squared plus bx times x plus 1 minus x, because I'm substituting c with -1. And I'm also going to substitute x for +1. So if I substitute x for +1, I have -1 is equal to b. So I'll simply take these three coefficients, 1, -1, and -1, and I'll substitute them into our constants. So we have 1 over x times the quantity x plus 1 squared is equal to 1 over x minus 1 over x plus 1 minus 1 over x plus 1 quantity squared.